亲爱的老师、同学和听众朋友们，大家晚上好，欢迎来到本期的科学之夜。我是今晚的主持人杨文瑜，来自云南大学。请允许我介绍本次科学之夜主办方 The Innovation 期刊。The Innovation 是一本由青年科学家与 Seal Press 出版社共同创办的综合性学术期刊，旨在鼓励科研人员专注于科学的本质和探索初心。期刊领域覆盖全部的自然科学。截至2025年，期刊的影响因子已达到25.7。同时的话 ，The Innovation 的姊妹刊 Innovation Water 也即将创刊。该刊物立足于地球系统的科学视角，旨在关注水在自然过程、生态系统与人类活动中的多尺度耦合作用，应对气候变化、环境污染、生物多样性退化与水安全等重大科学问题与现实挑战。欢迎各位老师、同学赐稿，也期待与您共建编委会。同时的话，也邀请您扫码关注 The Innovation 视频号，该视频号包含往期的跨年活动、刊物摘要、论坛等丰富的科普内容，为您介绍各领域的研究工作与科研突破。那么在此的话，请允许我介绍一下今晚的报告人，来自丹麦奥胡斯大学的 Erik Jeppesen 教授。Erik 教授的话是国际著名的湖泊学专家，同时的话，他也是云南大学客座教授。他的研究领域包括水生态学、气候变化、水体修复及富营氧化控制，发表论文近800篇，引用超4万次。他是生态学与环境科学领域前1/1000的高标准作者。同时的话，Erik 教授的话，2007年被授予诺贝尔和平奖，2021年也当选土耳其科学院院士，2025年获得国际生态研究所雪人泰奖。So I would like to introduce Professor Erik Jeppesen from Aarhus University in Denmark. As we know, Professor Erik is a world-famous expert at multiple fields, such as aquatic ecology, climate change, eutrophication control, and so on. He has been awarded numerous prizes over past decades, including Nobel Peace Prize, Academician of the Turkish Academy of Science, and top-tier foreign expert of China. 好，那么我们欢迎 Erik 教授为我们带来今天的报告，共同关注地下水开采对于干旱区湖泊生态的影响。So Erik, thank you for coming. We are looking forward to your report.
Thank you very much. And to the listener, welcome.
Okay, I just shut down my screen sharing and you can share your screen.
Okay. Thank you very much for this introduction. And today we are going to talk about global warming and also human effects on the water balance, salinity, and ecosystems in the dry climates. And it is becoming a problem that we are dealing more and more with globally. And I've been working with a lot of people in Turkey, so I present data from this work in Turkey and also from around the world, including also in China. There are a lot of warnings around, and they're very numerous. And I'll show you some examples here first before we go into more details. This is Lake Tuz in Turkey. And a few years ago, there were 50,000 flamingos in this lake. 50,000. It was 80% of the entire population in Europe that went there for breeding and also for taking up a lot of food. It's a very big lake, you can see. It's 1,663 square kilometers. And this is in 2021, and it's not ice covered, it's salt. And the lake has dried up completely in some periods there. And you can see to the left, you see the chicks of the flamingos. They are dead. There are other examples. The Aral Sea is the biggest lake one of the biggest lakes in the world. In 1968, it was 68,000 square kilometers. And nowadays, you can see it has shrunk almost to nothing. There's a little left up in the upper end, and I'll come back to that at the end of my talk. And in this case here, it's not only because of climate change, it's also because the rivers were directing away from the lake in order to use the water for agriculture. And this is one of the conflicts we have. You have both warming and we have also human activities. This is Lake Urmia in Iran, and you can see it's lost 90% of the water from 1997 to 2012. So it was before Trump entered into this place here. So you can see the salinity that the lake has shrunk, and you can see the salt all over there. And it is a lake that is 5,200 square kilometers. And it was an important freshwater resource in Iran, and it's now not usable at all. Here you have the Caspian Sea. It's actually the biggest lake in the world. And it's called a sea because it's like that. And you can see what the prediction is. This is the lake, how to the left you see the lake how it is now. And to the right you see the predictions by the end of this century. And this lake is 1,025 meters deep, so it will not dry out, but a large part of it will dry out in the northern and the areas around the lake. So it's a dramatical change also for this enormous lake. Here is an example from Turkey again, completely dead, no water left. And this is, instead of it's not the flamingos here, it is ducks that are dead here. And what is the reason for these changes then? Yeah, it can be climate change, and it can be water use, or what I call abuse, or it can be both. And if you ask the farmers, then nothing for discussion here. It is climate change, period. Because we work in nature. We know best how to handle nature, so we are not responsible. And this is what you see often with farmers. Of course, this is because they want to have a good income. And sometimes it's fertilizers. In this case here, it's because of water. But we can try to disentangle the effect of climate and also the use of water for agriculture. And a good example here is from the Great Salt Lake in US. It's also a very big lake, 4,400 square kilometers. And to the left, you see how the lake was in 1985. And to the right, you see in 2022, it has shrunk a lot, and it has lost 48% of the volume. And in this case, you have a chance to look a little bit about the reason why it has changed, because they have set up a very detailed hydrological model for this area, including the catchment, of course. And if you look at the blue line, then it's how the lake water level, the water level is to the y-axis is the water level, and the mean is 1,282 above sea level. And you can see that the blue one is going up and down, losing meters and they're coming back again, going up and down. But you're around the same line, the mean values 1,282 throughout this period from 1840 to now. So there has really not been a big change that can be attributed to climate. This is the climate effect you have there. But the red line, the red dotted line, is the actual changes. And you can see it's just going down and down again with fluctuations over time. But in total, you have lost, as I said, 48% of the volume. So this difference here is the use of water for agriculture. And of course, since the distance becomes larger and larger between the two lines, then it is because of reduction in the water table in the groundwater. More and more is used, and you lose the water in the groundwater and less water in the lake. And it's even worse now. And what has happened with us? What have we done, we human beings? If you go back in time, then this arid land was used for animals, farming. It was goats, or it was shown here, it was lambs and sheep, and they're just going around and picking up what they can get. But if you now look at the landscape, then you see the same most of the places, but you also see some very green spots there. And this is not because it's raining locally. It is because we take up water to irrigate the land, and then we can have crop production. And this is what we have done in many places of the world. This here is from northwest of China, and you can see this is the same picture here, more close up, very green, and then very gray and outside. And if you now look at the rivers in this area here in northwest China, you can see that the changes in water level in the river and the base flow in the wintertime, now in the summertime, is going down and down and down. And the red one is simulated, and the blue one is the actual measured. They're not so different, so we can trust if we go back in time, that was the water level back in time. So you're just losing the water in the river, and then one day it will dry out completely. This is until 2006. If we have crop production in these areas, it should be rain-fed. This means that you have winter weeds often, because in the winter you can put them out and then they grow slowly until you harvest them in summer, and you're basing it on rain. The production is not so high, but that's what it used to be if it was not animal farming. And this is an example from Kazakhstan, where they still do it and do not have the same problems as you saw there in northwest China, and what I will show in a minute from Turkey. This is Turkey, and you can see the same pictures I showed before from northwest China, exactly the same here. And there's not winter wheat. It is water-thirsty crops that they are using here, and therefore you need a lot of water. And even worse, you are using very costly water for this irrigation. You are using either the simple one at the bottom here, there's some just channel of water, and then the crops take it up, but you have a lot of evaporation there. And even worse, nowadays they use sprinkler up in the here up, and it's calculated that with sprinkler you lose more than 50% of the water just by evaporation, either when it goes down to the crops or on the leaves of the crops. You should use drip culture like you see here. This is the way to run it at, and you will lose much less water. But still, if you have water-thirsty crops, you still lose water. So it's not the perfect one, but it's better than the other two. And we have been running a project for 4 years in Turkey, and I'll show some of the results for this project, where we have looked at the effect of these activities on the lake ecosystems. And we have been looking both at the lakes along the coastal areas, and we have looking at the inland water. But I'll concentrate now on the inland water, and in this area here, it's the main area for production of crops and animals in Turkey. So it's important to look at this, what the consequences of changes in agriculture and also climate is in this area. And I'll show it's a closed basin, so they're not all water stay inside this area, and the water runs from this area here up to this area, and then become more and more saline. As you can see, this is the salinity out here, and you can see will come red, then you have very, very saline conditions. And this is the biggest freshwater lake in Turkey. And this is this Lake Tuz I showed before, where the flamingos are gone. So we are looking a little bit on this area. And this is the main crop production area in Turkey, this one, Konya Basin. And what you're seeing here over the time period where we try to put together the crop production, then you see that it's increasing slightly during this period from 1980 until around 2000. And then suddenly it goes up, dramatically increase. What is even worse is that it's the red one, sugar beets. They are very water-thirsty crops that you start to build up in a higher amount. And the other one is maize that also need a lot of water. So it's water-thirsty crops that you start to produce, where you have been a little bit more with wheat and so before. So it's not only this increase in production, triple of production, it's also that you shift to more water-thirsty crops. So it's much more than that. You can see the increase in water use here, going up here and dramatically increasing here. And this is what you see in this area in Turkey, because in part because there are more people now in Turkey. The population has doubled since 1950. So you need more production for that. But it's also because you have now better facilities for using the water. So it's not only because of the increase in population. And what is the consequences? Yeah, you can see it here. There are some wells, 1, 2, 3, 4, 5. To the left, you can see where they are. And then you can, to the right, see how the groundwater table has changed over time here. And what you can see is that some up here, it goes down and then it goes up again. And the only reason why it goes up again is because they pump water in from another catchment. It's up in number 1 here, so they take it from another catchment in here. But if you look at all the others, they just go down and down and down. And you can see it's not refilled. It's you coming up in the rainy period and then it goes down again. But it's all, you just go more and more down. And then you're losing 1 to 2 meters every year. And this is a dramatic one because you cannot continue with that. Then there are no water for the irrigation and so on. And this is what I always say, it's like to pee in your pants to keep you warm. It may work on a short term, you get production, but on the long term, perspectives are not good because you have to give up production at a certain point. So it's really bad that you have this lack of regulation. And many of the wells in this area are illegal. They are not registered, and therefore people just pump and change it, and no one takes care of it, you can see. The consequence is also that, of course, when your groundwater table goes down, then you have a cracking in the system. And this is an example where 1.5 kilometer crack, 2 meters wide. So it's logical that you get these people. Some people don't understand why it's coming. Why is this happening? Is it an earthquake? It's a sort of earthquake, but it's man-made earthquake. You have also other consequences, because when you all use all this water, sprinkling it, then of course the salt is staying while the water is evaporating. So the land becomes more and more saline and not so useful for crop production. So this is again peeing in your trousers to keep you warm. This works for a short term, but it will not last. And this is not useful for agriculture anymore. I'll show you that the consequences are dramatically from the freshwater ecosystem also. This is a lake called Lake Meka, and you can see it down here. It's a volcanic cone you have up here. And it's one of the major tourist places where people are coming down for sightseeing and looking around this beautiful place. But now it looks like this. There are no water. It's just salt that you see there, and it's gone, and there are no tourists coming here anymore. And you get the clear information from the sky, from the satellites. They can tell you the stories. This is from 1985 and until 2020. You can see water around the cone here very nicely, and continue. And now it starts to be white because it becomes saline, and then saline and saline and saline, and then disappear completely. And when do we see the most dramatical changes? We see it exactly here where we start increasing the production and where the water consumption increase. That's where it's all gone. And this is a very clear indication that this increase in production is very bad. And you can see the area of the lake is out here at a certain point, and then it goes down to nothing. And this is salinity opposite. So salinity goes up when it goes down here. So you have an increase in salinity until the lake disappears completely. Here in the same area, in the same Konya Basin, another lake, where you can also see how it changed over time. And in 2021, completely dry. We were planning to do a lot of experiments there, but we could not do it because it was gone. And it has, of course, dramatically effects on the ecosystem. And I'll just show it here with the bird species lost. 42 bird species have lost in this area here, and especially in the large marshes that have disappeared. And the endemic fish species are affected dramatically as well. And the endemic fish species are those that are only in this area here. And if they are gone for good. So we are killing some of the species in this dramatic go for water-thirsty crops. And you can see exactly against the same here, around 2005, some of the very important birds. This is a very endangered species, the white-headed duck. And you can see now it's gone from this area. Really big changes over a very short time period. We have another basin outside this Konya Basin. It's called the Bordeaux Basin. And it is tell more or less the same story. It's not exactly the same, but almost. And you can see there's a lot of lakes there in this area, and then there's some highlands and lowlands where the crop production is in the lowlands. And if you look at the lakes in this area, then you can see also again over time, shrinking, disappearing some of them. Same procedure. This is the crop production, also going up around the same time, very much increasing. And in this place, you have even increased the animal production also. So you need food for them, and therefore you have alfalfa, and you have also maize that are used for this. And you can see it's a water-thirsty crop, again, increasing dramatically during this period. And the same story, that the water bird abundance has declined quite dramatically over time in this area. What will now happen? This is agriculture, and it's also to some extent warming. But if it gets even warmer, what will happen then? What is interesting here, it's very bad for Turkey and also for part of China, is that with global warming, not only the temperature is changing, but the precipitation pattern is changing really dramatically. And you can see here in some areas where what the change will be by the end of this century here. We go sometimes up by 40% increase and sometimes down by 40%. The brown is down and the green is increasing. You can see in the northern part of the world, it'll rain more and more. And in Denmark, it's just raining. Where I come from, it rains and rains more and more every year. But in Turkey and this other dry area, it goes very bad. Depending on the scenario, 1.5, 2, or 2, 4. With 4 degrees, you can see really big changes, 40% reduction in precipitation in this area that is already dry. So it'll go very wild in this area. And part of China is the same. Other part of China get more wet also. And we have set up some models for some of the lakes there. And this is the biggest lake in the Bordeaux Basin called Bordeaux. And you can see how it has gone from this period, from one period to the next. Over 40 years, it has shrinked a lot until now. Then the shallower part has gone. But the calculation, you can see this is the calculation and this is the actual changes. And you can see that they follow each other. And the prediction by the end of this future is that this 40-meter deep lake is gone. So it's really bad also. Another example, that is what I showed before, the biggest freshwater lake in Turkey, also set up model system for this and included also land use effect. and try to calculate what the effects are in these 663 square kilometer big lake. We are not talking about ponds here, it's very big lakes. And the calculation, this is not so deep lake, so there's around 10 to 12 meter now. But the calculation for the future, whatever you take a soft scenario or more tough scenario for climate change, is that by the end of this century, it'll be gone most years. Sometimes it comes back again, but many years it'll get dry. And this independent on how you change the land use. So this is climate change effect. We have the land use in already, and now we have climate change on top of this. So really big changes. The biggest freshwater lake may disappear in Turkey. So the only water in these places that are left is from the crying of the people living there. And as I've shown you, dramatical changes occurring right now in arid and semi-arid climate zone. So far, mostly because of human use of water or abuse of water, I'll call it, but also added by climate change. And in the future, climate change will take a bigger role. There are massive changes in Turkey right now. And what are the consequences of this for these lakes that are not disappearing completely? They'll become very saline. And you can see the salinity here. It's from actually from northwest China near the Ulongur, Lake Ulongur. And there's dramatical effects on the ecosystem. There are both structural and functional changes. The diversity of everything will change. And you can see some of the examples here that the species richness will go down, functional diversity will go down, and there'll be a very big shift in the community in the system here over time. This is an example from Russia that have tried to put together data from many different Russian lakes and come up with this conclusion here. We did an experiment in northwest China together, so the expedition between Uruguay, Turkey, China, and Denmark up here in this area here near Urumqi. And I looked at all the lakes here with very different salinities and tried to see what are the changes. And the hypersaline weight was 150 grams. So it's a very big change from 0.5 to 115 grams. And what you can see here, it's a log scale here, the salinity log, and then the total number of taxa. So it's going straight down with increasing salinity. And since it's a log, if it was not log, it will go down like this very fast in the beginning and then level off. But really big changes in the number of species with change in salinity. So those lakes that survive will lose a lot of species and functional diversity also. Another example here is from the Tibet area. Some of the lakes in Tibet get more fresh or become bigger because they get water from the glaciers that are disappearing, but others get more saline where they are not connected to glacial water or get groundwater from the glacier. So in this area, you also see big changes in salinity. And looking at studying in these lakes, Lin et al. Looked at the salinity effect. And what they concluded, and we put into in a summary in innovation in 2020, is that if you have a low salinity, then you have a tree trophic level. You have fish that can tolerate low salinities. They eat the daphnia and the small copepods, and then there are less to eat the algae. So this is the situation. You have a tree level food web. But when the salinity come above a certain level, depending on where you are, maybe around 17 per mil, sometimes a little bit higher, then these fish disappear. They cannot tolerate it because the salinity is too high for them. And then you get a big daphnia because they are kept down by the fish normally, but now they tolerate it and they take the algae. But if you then go higher up, then they also go away because they have no chance with high salinity. Their osmoregulation is bad and they will die. And instead you get Artemia. That's the red one you see in many saline lakes. This is Artemia. That's what the one the flamingos are eating also. So that's where the flamingos come in. But if the salinity goes too high or the water disappear, then the flamingos got gone also. And you can see this is abrupt changes. It's not just some gradually changes. Here you see the shift from the Daphnia system and then to the Artemia system. And you can see here, which to the other way. So it's a very short, narrow salinity range where you get this enormous shift. And we see it also in a study that Lay is trying to finish now about the benthic invertebrate, this global data set, where you can see at a certain point that the salinity, then the invertebrates go down. And it's again log scale, so it goes very fast down here. The salinity, if it's if not a log scale, but a natural scale. Then you can see that there's a very big change here. And it's a little bit different from natural system and human system. The natural system have a lower threshold than the human system, probably because these systems, the human influence system, they tolerate it better because they are already affected by many other things that keep the more tolerant species running. So they're less affected by the salinity or tolerate it, but still at higher level, gone. We know very little about these saline systems, so that's a good work for many students in the future. And I'll show you here just between 2017 and 2021, how many studies that were done. Not very many, and it's mainly on invertebrate. There are a lot of things that are, a lot of areas that are completely open because people have not studied it yet. So this is a really good place for students to work in the future, also because it's a dramatical shift we are seeing now, and many more lakes become saline in the future. And you can see we need to do something. And it's time for action, else it'll go really bad in all the dryland areas. And same all over the world. They're not special. Turkey is probably very hard hit, but it's the same pattern in all places, as I've shown so far. What can we do then? We can reduce the greenhouse gases and increase carbon storage, so we are reducing the climate change at least. But this has to be done in the world, and this, of course, will also be done locally. But we also have to do something about the abuse of water, drip culture, not use sprinkler or more primitive methods. Have only legal wells that can be controlled by the government if they want to. But if they are not legal, you cannot control anything. And then you need to put a restriction on water use by farmers, and then use less demanding water crops. So there are a lot of things that can be done to avoid that it goes so bad as I've shown here before. We can also do damage control. The other thing is what we really have to do now. But damage control is needed in places where it's going very bad. And I'll just show one example. There are many other possibilities, but I'll show you one example. And now we come back to RLC, where they have done something. RLC, as you can see here, is disappearing. It's because of the abuse of water, taking the water away from the rivers. But now it's also climate change, and it's predicted that if nothing is done, then it is all gone in a few years. And then they decided that we try to save this one. This one cannot be saved. It's very shallow, and there's no hope. But up here is the possibility to do something. And this is what they have done in Russia now. And this you can see how the lakes looks like in the dry part down in the south. And the ships are still there, but they cannot be used so well. What they have done now is to try to save the upper part, as I show here, making a dam to save this part here. And you can see here what is happening then, that the water level in this area is increasing a little bit because of you have put out the dam, while in the rest of it is just going down and down and down. And they built this dam. First, it was a very primitive one that you can see this put here, and sometimes water run through it and destroy it. But later they decided to make a very big dam like this, not like Three Gorges Dam, but enough for stopping the water runoff from this area. Or not stopping it, but controlling it. And you can see what has happened then since the first dam and then the second dam. And then the salinity in this upper part is going down, and it's down now below 5 per mil, and less than it was in 1960 actually. while in the rest of the system, it's just going skyrocketing to a very high level of salinity. So if they had not done this, everything would be so saline that nothing could survive there. And this you can see in the upper dam, what is happening here. Back in time, you had a lot of fishery in this area, and a lot of different fish species also, really numerous species, 2011, and then it goes down to 5, and then it goes down to flounder only. And now in the upper part, you can see that they are coming back here again. So you see that the fishery is coming back, and people can now also start living on it to some extent in the upper part of the lake. This is still a big lake because the lake was 65,000 square kilometers. The upper part looks very small, but it's not so small. And now they also have tried to make it even better, that they try to transport water from one of the rivers into this lake, so they get 2 different salinities, 0 to 3. Some species of fish will live there, and the biota generally will be much more have much higher biodiversity. And then this one here is a little bit low one, and then it runs out by the dam to the dry land below. So this is the plan. It's not fully restored like that, but they have ideas to do that. So I will stop here. My talk is over, and thank the people that have been involved in all this. And then it's open for discussion, but we really have to do something. Thank you. Superman is needed.
Okay, so thank you, Erik. It's a very exciting report, and we would like to say thank you for your time. So here we have received multiple questions from the audience, and I would like to ask about these questions on behalf of them. Before that, I will let's say repeat the question in Chinese, and then I will translate them into English for you. 好的，那听众朋友们的话，目前有很多问题。第一个问题的话是关于降水的，有听众朋友们说，每年降水量丰沛的区域，地下水能否进行一个及时的补充？So Erik, they are wondering in the areas with the abundant annual precipitation, can the groundwater be replenished in time?
No, it cannot be. Anyway, we can say with climate change, there will be a reduction, but then there are some periods where you have more rain, and then they're filling up a little bit the groundwater resources. But the way they are doing it now is not sustainable at all, because the 1 to 2 meter down per year has nothing to do with climate change, as was also shown from the Great Lake not the Great Lake, but Great Salt Lake in America, that it is mainly because of misuse of the water at the moment. But in climate change, you'll also have problems that the water level will probably go down, but not at all like it is done now. And some years it will be refilled again. And you see that also in Australia in some places, that some years the reservoirs are almost dry, and then it's refilled a little bit because there are rainy periods. But overall, it will go down, no doubt, in these dryland areas of climate change, because of the precipitation is 40% less in some of these areas. So this means that it's not very good for agriculture in the future. But at the moment, they're killing everything.
Okay, thank you, Erik. We have another question. So, 有听众问到说，那些濒危特有物种，那么有实现迁地保护或者人工繁殖这样的干预的案例吗？ So Erik, they are wondering, are there any cases of an ex situ conservation or artificial breeding interventions for those endangered endemic species?
it depends on where you are, I think, because in Turkey they are not really doing anything for this. They are not gone, the fish yet, but they are endangered and they're on the way down. So, but there are no artificial breeding, but they will of course try to save them. I'm sure they will try to save them, but you cannot put them out. You have to save them like a zoo, because there's no. It's not helping them to come out in a place where there are no good conditions for them. They'll not just die. So it's you can try to save them in aquaculture systems or small ponds in other part of the country, but you cannot like a zoo, but you cannot put them back again at the moment. They're on the way out because of this. And 40 in Turkey, for example, 40% of all species are endemic of the fish. And they don't, it's not like pandas. They have not big eyes that they can say, see me, I'm very important. They're not looking like us. They can only come up of the water and say, blah, 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 blah. And we are not really thinking too much about that. So it's, and the reason why there are so many endemic species there is that when the northern part of the world was with glaciation, then these ones in Turkey was big wetlands. So there have been a long time of development of species. So that's why you have so many endemic species in these areas. And so now we are killing them, no doubt. We are on the way to do it. We are not very good with humans.
Okay, thank you, Eric. Okay, so another question. They said, OK，气候就是半干旱和干旱的气候区呢正在发生巨变，正如您说的，目前的话主要归因于人类用水，但是气候变化也逐渐加剧这一趋势。那么大家想知道是说人类活动和气候变化各自的贡献大概有多少？So Eric, you said that the arid and semi-arid climate zones are undergoing dramatic changes, mainly attributed to the human water use, but the climate change has intensified this trend. So they were wondering what are the respective contributions of human activities and climate change?
I think it depends a lot where you are in the world. But if you take Turkey as an example there, and also Northwest China, it's humans. It's cannot put the numbers on this, but I would say there's at least 90% or more at the moment. But in the future, the climate change will add to this, and maybe then the agriculture will die off, and then the use of water for agriculture will be less in the future because you cannot run it anymore. So it's but at the moment it is human induced reduction in water, no doubt. This climate is a small proportion of that. Of course, there are year-to-year variations, as you saw also again from the Great Salt Lake in America. There's up to 4 or 5 meter difference from one period to the next period. So there's a lot of changes from period to period. But overall, there were no real changes due to climate change for almost a 100-year period. But still, you lost 48% of the volume. So it's clearly a human-induced effect. So mainly humans, but in the future, perhaps more climate than humans. We don't know. It depends on human behavior.
Okay, thank you, Eric. Eric, now we have 1 minute tea break. You can have some drinks, and please allow me to introduce again about this journal. 好，听众朋友们，那我们中场休息一下哈。这次地方的话，我想再次介绍一下咱们的 Innovation 期刊。请扫码关注我们的公众号。The Innovation 微信公众号的话，它旨在把艰难晦涩的专业术语呢科普化，为您解读每一篇文章，与您一起理解科技创新的最新进展突破。所以的话，请扫码关注我们。
And I can recommend them. I can recommend innovation.
Thank you. Okay, so we are back now. We have one question. 有听众问的话是说，从畜牧向种植业转型，那么是否会就是说加剧了湖泊水位的下降？So Eric, they were wondering, has the shift from the animal husbandry to the crop farming intensified the decline in the lake water levels.
Yeah, if we think about animal farming as in the old days with goats and sheep and so, then it's a dramatical effect of the shift. But if you think about cows, where you also need to make crops like maize and sugar beets for them, then it's a different story, because this is then we are already taking water for this kind of production. So it's the goat and the sheep that eat what's there and live with the bad food there. But this was sustainable. But what we are doing now, either if we try to put in cows and then have to make a production for the cows, or we make a lot of crop production also for humans, then it's very bad. This has made the change. It's this shift from animal farming, natural animal farming, to more, you can say, intensive production. This is the reason why it's going so bad. And then also that the government in some places have supported that you make sugar beets, and this is really bad also, because it means that you use much more water.
Okay, thank you, Eric. One question. 有人问到说，当极度干旱的时候的话，人类会去取用地下水，那么去牺牲洞穴鱼类。所以的话，我们如何去平衡生物多样性保护和人类扶起呢？So Eric, you know that when the extremely drought happens, right? The human will take the groundwater and they will sacrifice the cave fish. So I was wondering, how can we balance the biodiversity protection and the human welfare?
Yeah, but it's clear that these changes we have in groundwater abstraction affect also cave fish. It's not only in the lakes, because the caves are also affected by this, and there are also endemic species in these areas in the caves, and Turkey has several caves. But I think that the only way is that we try to make the water use sustainable. It is not easy, because, as I said, in Turkey, they double the population and they need more food production. But we have to be more clever in the production. We cannot pee in our trousers. It's not possible to continue peeing in the trousers. And that's what we do now in many places. So to live together with humans, you have to make it sustainable production and find other places to do it. I know that they are interested in transporting water from one place to another. And this is bad for the ecosystem also, because they are normally, you can say, they have their own catchment, and they should have their own catchment and the water in the catchment. And this is also a problem we see in China now, where this pumping water into Beijing. I would say Beijing they should move the people, because it's not sustainable to have people up there under the conditions we have now. To have all these channels taking water from the Yangtze up to Beijing, this is wrong seen from an ecological point of view. It's good for those that need the water, but on the other hand, you're also losing a lot of water on the way to Beijing because of evaporation in these channels. They're open channels, so you lose a lot of water. So we have to think differently. We have to think in a better water balance, and not just make decisions that works for the short term. And so this my only recommendation is that we change this. And there are a lot of things you can do, like I said. First, to make the wells legal, else you cannot control them. And in 300,000 illegal wells in Turkey, that's what it. And some of those that are legal, there are also some bribery around this. So it's not always going as it should go. So we have to change that. Else we are living on the short term. And then it's like back in time, you remove the forest and then you have agriculture some years. And then suddenly you cannot have agriculture there because there are no nutrients left in the soil. So it's a little bit the same we're doing with the water now. And then you end up with soil that are salty and you cannot use it again.
Yeah, thank you, Eric. We have still 2 more questions. Okay. So one question is 有人问到说，那么这个 完全盐化的湖泊是否还会有环境效应呢？因为那上面的话，我们并不知道还有什么。So Eric, we were wondering, for the completely salinized lakes, will there still be any environmental effects? They were wondering what's even left on that.
Yeah, the complete dry ones, is that what you're saying? The complete dry lakes, there are a lot of problems with those. They know it from RLCs very well, because then you get dust, and this dust is full of a chemical of all kinds. And in this area, they had a lot of bad chemical production before, so the people get sick of this also. So it's the sediment which is changed to dust and running around, and people had to move also in many of the places because it's too dangerous to live in the area. So this is one of the consequences if big lakes get dry, that you get a lot of transport of pollutants that people take up, like air pollution.
Yeah, thank you, Eric. So one last question. 有人问到说，就是随着盐度的增加，那么藻类会具体发生怎么样的变化？能否请您做一些更多解释？Eric, so they're wondering how the algae will change with the increasing salinity. We were wondering if you could explain a little bit more.
Yeah, but this is this area that have not been studied so well yet. As I said, that we need much more data on this. But you often argue that you get more cyanobacteria, but it's not clear always, because in experiments we have done in Turkey, we end up with a mixture of diatoms and also cyanobacteria. So I'll not say there is a clear answer there, because we need much more data, and it depends also on the kind of salinity, because if you go to the inland lakes in China, for instance, in Tibet, it's not necessarily, it's not sodium chloride in most places, it's calcium or magnesium salts, and this have a different effect than sodium chloride. If you're on the coastal lakes, you get but you get often a shift to smaller species. So the smaller ones dominate, and the fewer species. That's what you see. But I'll not give a very clear answer on this at the moment. I think we need much more information on the effect of different kinds of salinities. So there's a lot to do for students. Just move on. I'm too old for that.
Yeah, thank you, Eric. So I think we have already asked all of the questions. 好，那么亲爱的听众朋友们，由于时间关系的话，那么我们今天的问答环节到这里。目前的话，其实我们还会收到很多听众的来信和问题。那么如果听众们对这个还很感兴趣的话，请扫码关注咱们的公众号或者微信频道，然后也可以通过邮件呢与Eric教授进行一个交流。同时也欢迎您加入咱们的学会微信群。那么我们最后的话，再次感谢 Eric 教授的这么一个精彩的报告。So thank you, Eric. Thank you again for your inspiring talk, and we learn a lot from that, and we hope that we can do something for the.
Thank you for inviting me to this late night talk.
Thank you for coming, Eric.
Yeah.
Okay. So bye bye. 好，那么各位听众朋友们，那么今天的话，咱们的科学之夜到此就结束了，也再次邀请各位听众去关注咱们的公众号、视频号以及扫码加入咱们的微信群，感谢各位，再见。